Hello everyone. As previously you have trained different models and compared different models using different evaluation matrix. In this lecture you will visualize the segmentation results where you will give the input image to the trained model and it will output the segmentation map. As you know that segmentation aims to develop a model which is able to extract and infer semantic information from the images at pixel level to recognize different items present in an image. So now you will give an input image to the trained segmentation model and it will output a segmentation map of the individual items present in the image. And we will visualize the output segmentation map with the original image, its corresponding label or its corresponding mask. So here you can see the original image and its corresponding label or its corresponding ground truth, and then you can see the predicted mask or the output segmentation map of the UNet++ trained model. So when we give the input image to the trained UNet++ model, it has produced this segmentation map of the original image. As you can see from the predicted output segmentation map, you cannot recognize the different food items. For example, if you consider the plate items, so you cannot visually recognize the different food items in the predicted output mask. So to cope with this problem, we are going to convert this image to an RGB image to label each item in the image with different color so that you can visually recognize the output segmentation map. So now you will decode the output segmentation map from 2D to RGB color image so that we will be able to recognize visually different food items in the output segmentation map. Now here you can see the original image and then its corresponding label or its corresponding ground truth mask, and then the predicted output segmentation map that we have obtained when we give the input image to the UNet++ trained segmentation model. Then we have converted this output segmentation map to RGB segmentation map, and in the RGB segmentation map you can see we can visually recognize different food items, and you can see we have assigned different colors to each item. For example, in the original image, if you see, this is soup, and here you can see the soup segmentation map. For example, if you see in the original image, here you can see the zucchini in the plate, and here you can also observe in the output segmentation map the predicted region of the zucchini with different color. So now you can visually compare the output segmentation map with the original image or with the ground truth, like how much region of the different items has been detected or has been predicted in the output segmentation map. So you will perform this visualization and you will see how we can assign different colors to each food item in the output segmentation map. So here is the Python function where we will assign different color to each class or each item in our dataset. So you can see the decode segmentation map and we have passed the image. Image is basically the output segmentation map, and you will also pass the number of classes of your dataset. So this function will convert 2D output segmentation map to an RGB output segmentation map where each label is mapped to its corresponding color. So let's see what we are doing inside this function. First, the variable class label colors stores the colors of each of the classes according to the index. The color for the first class, which is background, is stored at the 0th index of the class label colors list. Here you can see the background color is 00, that is a black color, and for each color 3 values are assigned that are basically the RGB values. The second class, which is a tray, is stored at index 1 and so on. Here you can see the tray and its assigned RGB values, and similarly cutlery and so on. So there are 43 classes and here you can see the 43 color values for each class. So now we have to create an RGB image from the 2D image we have. So what we do is that we create empty 2D matrices for all the 3 channels. Here you can see the RG and B arrays. These RG and B arrays will form the RGB channel for the final image. Each of these arrays is of the same shape as the shape of the 2D image. Now we will loop over each class color that we stored in class label colors, and we obtain the corresponding indexes in the image where that particular class label is present. Then for each channel we put its corresponding color to those pixels where that class label is present. Finally, we stack the 3 separate channels together to form a RGB image. Here you can see we have stacked the 3 channels and then we have returned the RGB image. Now let's switch to the Google Colab so that you can use this function and can be able to convert the output segmentation map to an RGB image. So to visualize the output segmentation map, first you need to get the original image and its corresponding mask from the test dataset. So here you can see we have used the test dataset, and here you can see the test dataset and we are getting the 4th image. and here you can see the image and its ground truth mask. Then we have converted the original image to a tensor so that we give it to the trained model. Here you can see the trained model dot predict, and we have give the tensor of the original image so that we can get the predicted mask. As previously we have loaded the UNet++ model, so here you can see trained model, and we have loaded the UNet++ trained model from the Google Drive where we have saved after training. And after we have defined the test dataset already, so we are using the test data to get the original image and its corresponding mask. And then we have given that image to the trained model so that it can predict the output segmentation map. Then here you can see we have converted the predicted mask to the NumPy. And in the next line of code, we have converted the predicted mask and the ground truth mask to the three-dimensional shape so that we can visualize the results. And also here you can see we have taken the transpose of the original image to make the format compatible for the visualization. And then we have passed image, ground truth mask and the predicted mask to the visualize data function that we have already defined and we have seen previously in the very start. So let's run this code and see the output. So here we go. So here you can see the original image. The original image color is different because we have applied the validation augmentation to normalize the image. So that's why its color is different. So original image and then its ground truth mask are labels. And here is the predicted mask of the original image that is produced after giving the original image to the UNet++ trained model. Now let's move forward to convert this output segmentation map to an RGB image. So first we will convert the predicted mask to the NumPy and get the predicted indices. So here you can see the predicted mask that is squeezed. So here you can see we have used the torch.argmax to get the predicted classes indices. And here you can see we have passed the squeezed predicted mask and then converted to the NumPy, and the result is stored in the predicted output. Predicted output variable consists of the predicted classes indices. Now we will get the unique indices from the predicted output so that we can print the individual items predicted in the output segmentation map. So here you can see we have used the for loop for I in indices and print classes and index I of that class and print corresponding class to that index as we have already defined our classes. So let's run this so that we can see what classes has been predicted by the UNet++ model when we give the input image. So let's run it and here we go. So here you can see the predicted classes in the output segmentation map. So here you can see the background, tray, cutlery, and if we go to the original image, we have the background and here you can see the cutlery and also tray. And then there is other classes like custard, soup and pumpkin, zucchini. So we have also custard and here is the soup. And here you can see the zucchini. So for this input image model have give very good result and predicted all the classes, and we can also see from the predicted output segmentation map that UNet++ predicted almost all the regions, and the predicted output segmentation map is almost same as you can see the ground truth mask. So now let's move forward to convert this output segmentation map to an RGB image. So here is our decode segmentation map function. We have already seen the detail of this function, and inside of this function we have assigned different colors to different classes. So let's run this function. Now you will pass the predicted output segmentation map and the number of classes to this function decode segmentation map function that we have defined so that we can get the RGB output segmentation map, and then we have uploaded this map. So let's run this and see the RGB output segmentation map. So here we go, you can see the colored output segmentation map where each item contain different colors in the output segmentation map. You can see the background color is black, and then each item in the predicted output segmentation map contain different color. Here you can see the tray, soup, zucchini, etc. Then you can save this RGB output segmentation map to the Google Drive. So here you can see we have used the cv2.imagewrite and we have saved the RGB map as RGB predicted map.png on this path in the Google Drive. So let's run it and it will save the output segmentation map RGB image into the Google Drive. Let's visualize another input image. So let's go back. So let's say we want to predict the image 1 and visualize its results. So we have changed the test data index to 1 and then we will run this code. So here we go and it's loading the results. So here you can see the input image, ground truth mask and its predicted mask. So now let's run this code to convert the predicted mask to NumPy and get the predicted class indices. So let's run this code. So here are the classes the model predicted in this output segmentation map, and then we will run this code to output the RGB segmentation map. So let's run it. So here you can see the RGB output segmentation map of the input image. So here you can see the RGB output segmentation map of the test image that is at index 1 in the test data. So similarly, you can save this image to the Google Drive with different name. So here you can see the RGB predicted map. This is the name that you can change and give different name and save to the Google Drive. So congratulations, finally you have visualized the segmentation results as well, where we have given the input image to the trained model, and trained model has predicted the output segmentation map, and then we have converted this output segmentation map to an RGB image so that visually we can recognize different items predicted region in the output segmentation map. And also we have output the classes that model has predicted. So here you can see for this original image model has predicted the background. So here you can see the background, and in the output segmentation map background is labeled as black. Then you can see the tray, and here is the tray in the original image, and here in the output segmentation map you can see the tray. Then cutlery, and in the original image you can see the cutlery, and here you can also see the cutlery with different color. Similarly here you can see the soup in the predicted classes, and the original image contain the soup, and here you can see in the output segmentation map the soup is predicted, and also the model predicted the custard, and here you can see the custard in the original image, and here is the predicted custard region in the output segmentation map. Thank you for joining this course. I really hope you have enjoyed the content and the diversity of the resources. Deep dive into learning, and good luck for your future success.